Well, hello everyone, and welcome to the 5th grade math prep talk for PLCs beginning the week of September 19th to help you prepare for the content that you'll teach in your classrooms the week of September 26th through the 30th. We really hope that this video is informative for you and helps you to be a contributing member to your PLC as we look at some of the star-released questions from the lessons that we'll cover the week of September 26th. So as we dive in and look at the overview of the week beginning Monday, September 26th, you'll see that we'll spend 2 days estimating solutions for all operations, primarily where we are having students round from a decimal to a whole number in order to estimate the solution to a real-world problem. We're going to spend 2 days on that. You'll notice that it is a supporting standard. It has been tested 4 times in the last 5 years, but it is such an important skill for students to be able to master because it will help them in other TEKS. For example, 5.3K has students solving problems where they have to add and subtract positive rational numbers fluently. You'll see that that TEK has been tested 10 times in the last 5 years, and if you look through the released items for each of those years, what you'll notice is that if students can master the idea of estimating to determine their solutions in TEK 5.3a, then they're going to be able to eliminate some wrong answers whenever they come across a question in 3K. So we're hoping that the work that you do on Wednesday and Thursday will help support the work that you'll be doing Friday and then the following Monday when students are adding and subtracting decimals. As we look at this star-released item, I want you to notice that the student is going to have to determine whether they're supposed to add, subtract, multiply, or divide in this real-world situation. This is where it's really important not to teach your students key words, meaning I see this word, so I'm going to do this operation, but to teach them academic vocabulary and immersing themselves into the word problem by closing their eyes and imagining the situation so that it becomes clear what operation they should use. What you'll notice in this problem is that we will be adding the amounts that Shane spends on a shirt, a pair of pants, and on a hat, and we want the best estimate for the amount of money in dollars that Shane spent. One misconception that we see often on these types of problems is that students will take the numbers that were given in the problem, $15.45, $21.99, $12.15, and add those decimals the way they are presented in the problem, and then round their answer at the end to get one of the whole number answer choices. That really defeats the purpose of the effectiveness of estimating in order to determine a solution. It's much easier, as you well know, to round these 3 numbers and then add them together in order to get an estimate for the amount of money that Shane spent. So if we start with that work, starting with $15.45, we know that that is going to round down to $15. $21.99 will round up to 22 whole dollars, and $12.15 will round down to 12 whole dollars. We'll then be adding these 3 numbers together. In the ones place, we will be getting 9, and in the tens place, we will be getting 4. And so what we see here is that my answer is closest to 50, and so that is going to be the best estimate for the amount of money in dollars that Shane spent. This released question says that Paula wants to buy 3 shirts and 2 belts, and we are given the cost of the shirts and the cost of the belts, and told that Paula has $45. We want to know which amount is the best estimate of how much more money Paula needs in order to buy the shirts and the belts. This is actually a 3-step problem if you think about it, because we have shirts and belts, the cost, but we know that we're going to have to multiply the cost of the shirts by 3 and the cost of the belts by 2. After we do that multiplication, we will have to add those 2 numbers together and then subtract from 45 in order to get our answer. That is a lot for students to have to process through. this might be a great opportunity to plan a turn and talk where you have students turn and talk to their partners about how they would go about setting up this problem and how to solve it. This will give you as the teacher a chance to get real-time data about where your students are in the problem-solving process and be able to redirect any misconceptions that you might hear as you walk around the room and listen in on these conversations. After you have students come all back together, have some people share out, and then you can redirect by asking other groups whether they agree or disagree or have anything to add on to what has been said. This can really cultivate a culture of student discourse in your classroom around the problem-solving process. What we see here now is that we have 3 shirts and 2 belts, and so the shirts each cost $16.89. Because I want the best estimate of this amount of money that Paula needs, I know that I can round 16.89 to 17. And so for shirts, I know that I'm going to be multiplying 17 times 3 since she wants to buy 3 shirts. This is going to give me 51 for the cost of the shirts. Then for the belts, we see that the belts cost $8.97, reminding students that that can easily be rounded up to 9 whole dollars. And so 9 times 2 belts will give us the total cost of the belts. Then we will want to add those 2 numbers together. And so that will give us the total amount that Paula will spend on the shirts and the belts. 51 plus 18 will give us 69. Then what we notice is that Paula has $45, and so that means we're going to have to subtract 45 from 69 in order to determine how much more money she is going to need. And so here is step 1, here is step 2 of this problem, and step 3 is going to be that $69 minus the 45 that she already has, which is going to give us $24. Notice that there's only one answer choice that's even remotely close to 24, and so that answer choice will be the correct answer. This is another problem where students will have to think through which operations will be required in order to solve the problem. One activity that you could consider here is called 1-3-6. This activity has students thinking independently at first about what operations will be needed and what path will be taken to solve this particular problem. Once they've had that time to think independently, they move into a group of 3 and compare their thought process and what they came up with 2 other people in a small group. Once they have a consensus and maybe fix some mistakes and clear up some misconceptions in their group of 3, they then move to a group of 6 to do the same thing. And so then you can have students share out, ask other groups if they agree or disagree or have anything to add on to what was said, and really get student discourse going in your classroom. In this particular problem, we see that Mr. Marquez has 123 eggs in a refrigerator in his restaurant. He put 32 more cartons of eggs in the refrigerator, and each of those cartons contained 18 eggs. We want to know which of these is the best estimate of the number of eggs that Mr. Marquez now has in his refrigerator. So what I notice is that I've got to figure out, first of all, how many eggs he put into the refrigerator from these additional 32 cartons. That means that I know these 2 numbers are associated with one another. And to figure out how many eggs come in those cartons, we're going to multiply 18 by 32. But remember, we're only looking for the best estimate. So instead of multiplying 18 by 32, we could instead round 32 to 30 and 18 to 20 and multiply those numbers instead. Now, multiplying these with the trick of zeros, we would see that 3 times 2 is 6, and then add 2 zeros on the end. Now, you're going to notice that that is an answer choice, and that answer choice is for the folks who forget that there were already 123 eggs in the refrigerator before Mr. Marquez started adding additional eggs. And so we've got to remember to also add those 123 eggs. But again, because we're estimating, we could really round that number to the nearest 100 and get a result of 700, which in fact is the correct answer in this particular problem. What's interesting is that when you analyze the data, this answer choice right here is actually the most common wrong answer. And I think it's okay to talk to students about that. Maybe ask them, why do you think someone would have picked 600 instead of 700? What step would they have forgotten in order to arrive at F as opposed to H? Those can be good illuminating conversations for students to be a part of so that they are less likely to fall into a misconception. As we move into TEK 3K, we see that we're going to have to actually add and subtract these decimals in order to find the exact final answer. But we can still use the idea of estimation to help us at least eliminate two wrong answers, as I'm going to show you at the end of this problem. What we see is that Landon had one string that was 10 meters long. He used 6 275 thousandths of a meter of this string for a project. We want to know the length of string in meters that Landon had left. This is one of the rare one-step problems that students are asked to solve, and hopefully what students will arrive at is that subtraction is the necessary operation. Now, this is where you're going to want to make sure students understand that when we add and subtract decimals, the most important thing is that they line up the decimals. We have 2 videos in our curriculum that you could possibly show to students to engage them and hook them at the beginning of the lesson as a reminder that if we don't line up our decimals, we will not be adding and subtracting correctly. And so what I see here is that I have a string that is 10 meters long, and I'm going to be subtracting from that 6.275. So I know that even though this 10 does not have a decimal, every whole number has a decimal after it. And then I can add as many zeros to the end of that number after the decimal place as I need to. And so in this particular case, because I'm subtracting 6.275, I need to have 3 zeros after my 10. Then I can effectively put 6.275 down with the decimals lined up exactly the way they should be. One thing we would highly recommend is to have students do this on grid paper. They can use that on the STAR test, and that will help them line up the decimals and the place values correctly for whenever they solve this problem. Now, what you're going to notice is that the subtraction here is very ugly because we have a lot of zeros in that top number. And so when I first of all try to subtract 5 from 0, that doesn't work out too well. And then when I try to borrow from the hundredths place, that doesn't work. Then I borrow from the tenths place, there's nothing there to borrow. I don't get anything to borrow until I get all the way to the tens place. And so that's where I have to actually start borrowing from. And so this is going to become a 0, which means that this is going to become a 10. But then I still have to get all the way to the thousandths place, so I need to borrow from that 10 and make it a 9 and make this a 10 in the tenths place. Well, I'm still not at the thousandths place, so I'm going to have to borrow from the tenths place to get to the hundredths place. So now I've got 10 in the hundredths place, but that's not good because I still need to borrow to get back over to the thousandths place. So one more time, I will scratch that 10 out and put a 9 so that finally I can get 10 1,000ths in the 1,000ths place. Now I am ready to actually do the subtraction. 10 minus 5 is going to give me 5 in the thousandths place, making sure that I have my decimal lined up. Then 9 minus 7 is going to give me 2. 9 minus 2 will give me 7. 9 minus 6 in the ones place will give me 3. And I've got nothing in the tens place to subtract. And so my answer is going to be 3.725. But watch this. If we just use estimation to help eliminate a couple of wrong answers, then what we realize is that if we round this number to a whole number of 6, then 10 minus 6 is going to give me 4, and I automatically eliminate 2 answer choices that are too far away from 4. However, what you need to be careful of is that students don't just take this shortcut, because obviously if they do and they arrive at 4, they may think that G is the correct answer since there is a 4 in the ones place. So be careful to weed out that misconception when you're talking about reasonableness and estimation. You may think about talking about, if I take away the 6, that's going to give me 4, but then I'm going to take away another 275 thousandths, which is going to put me below 4 and in the 3 range, and that would make sense with how we got the correct answer. As we look at the next question, you'll notice that this is a 2-step problem. Mr. Wilfred used a full 2-liter bottle of liquid soap to fill 2 soap containers. He put 475 thousandths in one of them and 35 hundredths in another one. How many liters of liquid soap remained in the bottle? So what students will have to recognize is that we have to add the 0.475 and the 0.35 first, and then subtract from the 2-liter bottle. If we start with the addition, 0.475, 0.35, again making sure that students are lining up their decimal places, using grid paper, or if you're just using regular scratch paper, checking to make sure that students are doing this, because it is one of the biggest misconceptions and problems that we see with adding and subtracting decimals. The other thing is making sure that students realize that if I have 35 hundredths, I can put a 0 there to make that 350 thousandths. Okay, so now we are ready to do the addition here. 5 plus 0 is 5. 7 plus 5 is 12, adding a 1 to the next place value. 4 plus 3 is 7, plus that 1 is 8, and I do not have anything in the ones place. Great, so now I have the amount that was put into the 2 bottles total, and I want to take that away from how much was originally in the 2-liter bottle. And so once again, lining up the decimals, as you can see, is going to be very important. And so 2, after the 2, I'm going to put a decimal, then my decimal for my next number is 825, and realizing that I'm going to put zeros in those 2 places there. Now, you'll notice that this is very similar to the previous question that we just did, where we had to borrow down several place values in order to use the standard algorithm. You and your team as a PLC may discuss a different strategy to have students solve subtraction problems such as this, maybe as a way of counting up. So I could count up by 75 1,000ths to get to 900 1,000ths, and then another 100 1,000ths would get me to 1, and then I could get to 2 just by adding a 1. And so that might be an idea that you talk about in your PLC, or if you want your students just to use the standard algorithm, that will work as well. So I'm going to have to borrow or regroup here from this 2 in the ones place. That's going to make this a 10 initially, but then have to borrow again from that to make this a 10 in the hundredths place, then borrow from that so that I can make a 10 in the 1,000ths place. Now doing the subtraction, 10 minus 5 is going to give me 5. 9 minus 2 is going to give me 7. 9 minus 8 is going to give me 1. And in the ones place, we still have this 1 right here, minus the 0, which is going to be 1. And so 1.175 will be the correct answer to this problem. But wait just a minute. We could have used estimation in order to get close to the correct answer and at least eliminate a couple of wrong answers. What I noticed first is that I could have rounded this number to the nearest tenth, which would give me 0.5, and then I could round this number to the nearest tenth, which, because that's at the midway point, would round up to 0.4. Then adding those together seems pretty straightforward. There's not really a ton that's difficult about that, other than, again, making sure that we line up the decimal point to get 0.9, and then subtracting 0.9 from 2. Well, what we can do there is just, once again, borrow, make this a 10, and then 10 minus 9 is 1. 1 minus 0 is 1. And so we arrive at an estimate of the answer of 1.1, which, as you'll see, is pretty close to the final correct answer. Now, as you saw in the previous problem, we don't always want students to just estimate in order to get the answer on a multiple choice problem. And furthermore, sometimes these are tested as equation editor or text entry, formerly called griddable questions. So they will have to be able to do this fluently the real way. But the estimation or reasonableness can at least help you eliminate some potential wrong answers on a multiple choice problem. So keep that in mind, that you can always refer back to the lessons that you taught Wednesday and Thursday on estimation to help with these adding and subtracting positive rational numbers problems. Let's work one more problem just for good measure, this time in the context of money. While cleaning his room, Paul found 7 cents on his desk, 98 cents under his bed, and $2.04 in his closet. What was the total amount of money that Paul found? Students need to be able to identify that we will be adding these three numbers together in order to get the total, but we've got to write them down as correct decimals. One of the biggest misconceptions will have students writing 7 cents down as 0.7, but remind them that that is actually 0.70 or 70 cents. And so we know that that is not the correct way to write that particular number. And so what we're going to have to do, and it's not letting me erase that, so I'm just going to scratch it out. We have to remember that 7 cents is actually 7 out of 100 cents, or 7/100ths. Then 98 cents, lining up my decimal place, as always, will go underneath that. And then $2.04. Again, making sure they don't write it as 2.40, but instead as 2.04. Then just adding using the standard algorithm, 7, 8, and 4 is going to give me 19. Add 1 to the tens place is going to give me 10. So put a 0 and add 1 in the ones place. 2 plus 1 will give me 3, and we get $3.09. As we begin to wind down this video, I want to remind you that we've only looked at a handful of the released questions for these two TEKS that you'll teach the week of September 26th. But STAR has released a lot more questions that you should both read and solve in order to have a thorough understanding of how that TEK works and how it is tested on STAR. And so the breadcrumbs that STAR likes to give us and lay out for us, we want to make sure that we pick those up, that we're understanding some of the clues and hints that we're getting from previous questions, because although they will never ask the same question twice, the types of questions and sort of the flavor of the questions tends to remain the same, or at least be very similar to what we have seen in the past. And so make sure that as a part of the pre-planning process, you are going back and working all of the released items so that you are adequately prepared for your PLC and ready to plan a great lesson to help your students add and subtract decimals. If you have any questions in that process, we will hold office hours again the week of September 19th. On Tuesday, September 20th at 3:30 until 4 o'clock. So if you have any questions about this week in 5th grade math, please be sure to hop on and ask that on our Zoom office hours. And if you aren't able to make it to that, you can email either myself, Ryan Castle, at rcastle@mesquiteisd.org, or our wonderful 3rd through 5th grade math facilitator, Sherry Height, at slhite, that's HITE, at mesquiteisd.org. Before you go, we would ask that you fill out this survey so that we can know that you watched the video, and also your feedback will help us serve you better in future videos. Thank you again so much for joining us. We hope this was a helpful time for you to get a better understanding of how these two TEKS work in 5th grade and how you will best deliver the instruction to your students. Good luck, and please let us know if there's any way that we can help or support you.